Hi, today we're working on 6.1, the fundamental property of rational expressions. Please go through and read all that's required of you. My goal right now is to go over all of the examples. And here we go. First of all, a rational expression is when you have an expression that can be in the form of a fraction. And you can never have zero in the denominator. That's what this here says. So my first objective is to find the numerical value of a rational expression. Here's my examples. I'm going to scoot this over a little bit so I can write. And here we go. First of all, find the numerical value of each expression for x equals 3. Wherever there's an x, you are going to put in the number 3. So I was trying to write on something that's not here. All right, so the first one, what I'm going to end up doing is this. I personally like to put little blank spots wherever the letter X goes, okay? So wherever the letter X goes, I like to put in, one second, let me pause this for 1 second. All right, I'm so sorry. First of all, wherever there's an X, I like to put in a blank spot. That is where I'm going to put in the 3. The reason why I'm going to put in the 3 is because it tells me X is equal to 3. So wherever there was an X, I am going to go ahead and put in a 3. So in the numerator, I have 3 plus 1, which is 4. In the denominator, 2 times 3 is 6. 6 plus 1 is 7. Now, I cannot reduce that fraction. That is it. Now, the next problem. Once again, wherever there's an X, I'm going to put in a blank spot. Okay? So what I'm going to do now is, wherever there's an X, I'm going to put in a 3. So all those little blank spots, I'm going to put in a 3. 3 minus 3 is 0, so the numerator is 0. 3 times 2 is 6. 6 plus 1 is 7. 0 divided by 7 is 0. Now, for the next one, I have 2 times something plus 1 over something minus 3. Once again, x is equal to 3, so wherever the blank spot is, I'm going to put in a 3. So I get 7 over 0. We are not allowed to have 0 in the denominator because that is known as undefined. We learned that in chapter 3, I believe. All right, can never have 0 in the denominator. Now, let's jump to the next part. With these ones here, what's going to happen is when you're trying to find the denominator of a rational expression cannot be equal to 0 because if it is, it's considered undefined. So a lot of times they want you guys only to tell them what x cannot be. So a lot of the times we don't care what's in the numerator. The only thing that we worry about what's in the denominator. So we take whatever's in the denominator and we try to solve for x. Whatever that number happens to be, that's what your x, it's all real numbers except that number. Whatever that number happens to be, if you subtract it by whatever the expression is, you could get 0 in the denominator, and you cannot have 0 in the denominator. So let's actually do a problem just to make it easier. Please read through this on your own, but let's actually do a problem. So let's just go through the steps real quickly. Step 1, set the denominator of the rational expression equal to 0. Only look at the denominator. Solve that equation, and then whatever you end up getting, it's all real numbers except for that number. All right, and I'll explain to you what it means right now. All right, so let's say they want you to find values that make rational expressions undefined. Don't worry about the numerator. Only look at the denominator. So I'm going to take the denominator and I'm going to set it equal to 0. Now I'm going to solve for x, which means I'm going to isolate x. So I'm going to add 5 to both sides, and x equals 5. Now, if x actually equaled 5, 5 minus 5 is 0. You can't have 0, all right? So x cannot equal 5. Okie dokie. All right, next one. Let's do the next one. Now, once again, I could not factor this, like I couldn't cancel anything out. So that's why I had to solve it. Now, this top one here, I don't care what's in the numerator, but I do need to factor the denominator. So what's going to happen is I'm going to end up with this 3r over something times something. Now I'm going to factor the denominator. First of all, I know I'm going to have two sets of parentheses. The only way to get r squared is r times r. I'm going to look at this 8 right here. I'm going to find two numbers when multiplied together give you 8, but when added together give you 6 because that's the middle term. So I know that a positive 4 times a positive 2 is 8. I also know that 4 plus 2 is 6. So that's my two factors. So I'm going to have r plus 4 and I'm going to have r plus 2. Now, after you have factored it, what you're going to do now is you're going to take what that denominator is and you're going to set it equal to 0. So r plus 4 equals 0 or r plus 2 equals 0. And then you're going to solve for r. In this case, r is going to be negative 4 or r is going to be equal to negative 2. So as long as r is not equal to negative 4 or r is not equal to negative 2, you're good to go. All right, so negative 4 and negative 2 make the denominator undefined. Well, it makes them 0, which makes them undefined. Okay, now let's do, whoops, where'd it go? Let's do this one here. Now, I'm only looking at the denominator. So I get z squared plus 9 equals 0. I'm going to subtract 9 from both sides. And you're left with z squared equals negative 9. Now, only because you guys have had algebra 2 before, if I square root both sides, I'm going to get z equals plus or minus 3i. Now, I cannot have z be equal to a positive or a negative 3i. Because this is college prep, you should know that because you had algebra 2. However, z cannot equal positive or negative 3i. Okay? And that is, and you had this in algebra 2. It's about imaginary numbers. So I just wanted to kind of throw that out there. All right, next one. This one is about reducing your fractions. So what we're going to do right now is we're going to reduce these fractions. You did these since middle school. You're going to try to find a number that can go into 15 and 45. So I'm going to start with 15, actually. I'm going to start with 5, you guys. If I know that 5 goes into both of them, and that leaves me with 3 over 9. I also know that 3 goes into 3, and I know that 3 goes into 9, so I end up with 1/3. That is one way of doing this problem. Here's another way. Find the largest number that can go into 45 and 15. You would get your answer faster. I know that 15 goes into 15 once. I know that 15 goes into 45 3 times. By dividing the numerator and the denominator by the largest common factor, it just makes you get to your answer quicker. Does not mean that it's perfect. Now, remember when you divide powers, you subtract the exponent. So because I have a fraction here, I'm going to write a fraction there. I might not use a fraction, but that's what I'm going to do. Now, 2 goes into 2 once, 2 goes into 6 3 times, so 3 is here. P cubed divided by p squared is p, and then you're completely finished. Sorry. Now, you just leave it as 3p. That's your answer, 3p. Remember, when you divide powers, you subtract the exponents. When you multiply powers, you add the exponents. And when you raise the power to a power, you multiply the exponent. So these are all things you learned in the past units, and we're going to keep going. All right, now what happens if you have a fraction like this and they want you to reduce it? Well, the first thing you have to do is you have to factor the numerator and you have to factor the denominator. And then if you can reduce it, you do so. So I'm only looking at the numerator. They both share a 2. The 4 and the 2, they share a 2. Okay? So I'm going to be left with 2y plus 1. If you don't believe that, 2 times 2y is 4y, 2 times 1 is 2. So you know you've got that done. Now I notice these ones here share a 3. And once again, 3 times 2y is 6y. 3 times 1 is 3. So I can check my answers by just distributing it. Now, this cancels out with this, and you get 1. So my answer is going to be 2/3. Now, we have to remember what we learned in the last chapter. For the first part, this is actually known as the difference of squares. I know that because I could square root the first term, I could square root the last term, and they're separated by a minus sign. So I end up with a plus b times a minus b. That's a difference of squares, and there's a formula for that. Please look it up if you don't know it. Now, this bottom one is actually known as a perfect square trinomial. I know this is going to be a because the square root of a squared is a. The square root of b squared is b. And this plus sign in the middle tells me I'm going to have a plus sign here. And then I know that this is going to be squared because that's the formula that I gave you a while ago in chapter 4. Now, here you're going to cancel this out. Now, if you want to, you can actually write this out twice. So a plus b times a minus b over a plus b times a plus b. Remember, I have 2 of those. Now again, the a plus b's cancel out to 1. And you're left with a minus b over a plus b. I am going to stop there, and let me see how much further I have to go. I think I need to stop there. It's going to get long. So I'm going to stop here, and I will catch back up with you guys in a few minutes, okay? Have a great day, and I will see you in the next video.